Hey, folks, honestly, it is sometimes difficult to relate a math concept to the real world or vice versa, like a real world to a math concept. It maybe is impossible to do it every single time. So I'm doing my best to show you a situation where we have these vocabulary words involved. It's not perfect. I acknowledge that. So let's keep going with this idea for a little bit longer and see if it has some weaknesses to the argument. Okay. And I want to clear one thing up. In my first video, I may have said, like independent, dependent in science, but I mean, that's more math. Independent is the X variable, dependent usually is the Y variable. And in science, they call it the responding variable, I think, the Y, right? And the control variable is the X. So anyways, I just want to clear that up. It was bothering me. I'm not going to make a whole new video on that. But anyway, let's take our function. What do we have? We have a function that looks like this. Let me show you a picture. Uh, it looks like, oh, not that one. It's this guy right here, y equals 2x. And let me zoom in on that guy just a bit, okay? So why is this my function? Well, because the amount of cheese we need is the number, at least not the units, but the amount of cheese is 2 times whatever the number of beef we have, right? So it is this y equals 2x function. But I have a little bit of a weakness here because I was initially claiming that you can have like half a pound. So here is 1 pound, 2 pounds, 3 pounds, 4 pounds of beef, and then you can't have anything in between. So I need a way to show just dots instead of this whole number. And plus, you can't have negative amounts of beef. So this is where really kind of this math function idea has some weaknesses, like applying it to the real world. So one way I could limit this is I could put some curly brackets, and this starts looking like set notation. But instead of putting X and then a vertical bar, like in set notation, in Desmos, you just go X greater than. Okay, so if I go X greater than 0, it restricts my line. So this is a little bit better. My function now is starting at 0. I mean, that's definitely better, right? And then, by the way, is this even a function? Do you remember the idea of a function? That, like, if we had 5 pounds of beef, how much cheese do we have? We have 10 pounds of cheese. So let's look back at our table. For each X value over here, there's only one Y value over here. So if that is the case, then it is a function. I'm going to try to put that right here. For each X value, there's one Y value. Each X has one Y. Okay. Now, why is that important in mathematics? Well, if there was some kind of variability in our recipe, like 1 pound of beef, you could put 3 cups of cheese or 3 cups or 4 cups. Well, in the real world, that's reality. I mean, that's true. You could put however much cheese you want in there. Or if you have some lactose issue, then you leave the cheese all the way out. I mean, that's the science of, or the art of cooking, right? You can do different things. Now, if you have a big food chain, you might want to have things consistent. So this variability would not be a good thing because some people might not like when they show up, at one restaurant in one town if the recipe is different than another town. So if we want consistency, then we want to keep it to a function to where only one Y value pops out when we plug an X value in. So if I go to 3 pounds of beef, I know that I'm going to use 6 pounds of cheese. So there's definitely a one-to-one relationship here. Now, that's a little tricky because they use this word one-to-one to mean not only each X has one Y, but each Y would have only one X value. So in this function right over here, so far this is a one-to-one function because if I go over to 5, I go up to 10. If I come up to 10, I go back down to 5. So there's no ambiguity in this relationship. Now, if I changed my function, let's say I had like absolute value. Check this out. Oh my goodness, this is gonna be crazy. Let me get rid of this for just a second, okay? And I got to move this guy over, and let's go into functions, and let's go down to absolute value function. So the absolute value function, did I pass it already? Well, we could just type in ABS, but I was looking for the little vertical. Oh, wait. It's right here. Sorry, folks. So I'm going to put 2x inside the absolute value function, and I want you to see what this looks like. Okay. So this is still a function because if I go over to 5, I go up to 10. But now when I go up to 10, I can go to two different values for x. Now, I know what some of you are saying. Well, this isn't realistic for a cooking problem. You can't have negative 5 pounds of beef. You're exactly right. But in a math, like when we start talking about just understanding functions in a deeper level, then we need to understand this idea as well. So a one-to-one function, okay, let's add this right now. A one-to-one function means that for each x has one y, and this is super important, and each y has one x value. Okay, so how do you test that out? Well, they talk about something called a vertical line test. If I go vertically and it only hits the function in one spot, then it is a function. If it only hits the relation in one spot, then it is a function. If I can draw a horizontal line and it crosses in two places, then it's not one-to-one function. It's not a one-to-one function. If it only crosses in one place, like I get rid of the absolute value, okay, then it is a one-to-one function. Now, this is a one-to-one function because the vertical line test, it only hits in one spot, and the horizontal line test, it only hits in one spot again. So we're going to practice this idea on some more homework, but that's the idea of a function and a one-to-one function. Now, what is this thing about onto? Let's talk about that for a second. Onto is a word that this book uses to mean that the codomain is equal to the range. So let's study this situation for a second. We said the codomain is the same really as the domain, unless somebody says otherwise. And so what do we have? We have all the integers, 1, 2, 3, 4, 5. And then over here, we have the range, 2, 4, 6, 8, 10. Well, these numbers do not match up exactly with those numbers, because if we start describing these numbers are the even numbers, right? There are no odd numbers over here, right? So no odd numbers. But over here, there's an odd number, right? So these are just all the integers. So these are all integers. So the codomain, this is our codomain over here. It's really the same. Let me spell that a little bit neater here. Write that out a little bit neater here. The codomain is all integers and all positive integers. And this one over here is all even integers. So let's put range over here is all even, which we've already written, I think, somewhere over there, right? So because the codomain does not equal the range, then it's not onto for our situation over here. So we're gonna do some more problems in class together on how this works, and talk about it. So if this isn't making total sense, I appreciate you getting the notes down, and then we're going to see if we can apply the notes. Thanks for watching.